Hello everyone, today I'm going to show you how to set up P2PP in Slicer or Slick3R or however that is supposed to be pronounced. I'm going to use PrusSlicer 2, so I'm going to avoid the whole name thing. PrusSlicer 2 is a clone of, and there we go again, Slice3R that Prusa made to slice for their printers, but it can be used for any normal FDM printer. I use it for my heavily modified CR10S and it works just fine. P2PP is a replacement for the Mosaic Chroma tool. Chroma is used to convert a multi-extruder G-code file to single extruder multicolor. So it generates instructions for the Palettte to tell it when to splice in the different materials and when to send pings back to the Palettte. So instead of you could use Chroma with PrusaSlicer as well. You just slice it using multiple extruders and then run it through Chroma, like you could do also with Simplified 3D or Cura or any other slicer that they support. But the cool thing with PrusSlicer 2 and P2PP is that it's all integrated in one package. So you click slice and out comes an mcf.gcode file that you can send directly to your Canvas hub and then print in multicolor with the Palettte. It requires you to use connected mode. It doesn't work with accessory mode. So for this tutorial, I'm gonna assume that you have already set up PrusSlicer 2 for single color printing on your printer. If you need help setting up, like if you've never used PrusSlicer 2 before or Slicker, I assume Slicker is similar. I had never used any of this before I wanted to try out P2PP. So I'm not really an expert on PrusSlicer 2. PrusSlicer 2 is also very new, and I'm not sure exactly what's different between that and stock Slicker. I believe the P2PP script will work for all the versions, but I've only tested it in PrusSlicer 2. So let's first download P2PP and the prerequisite software needed to run it. Here is the GitHub page for P2PP. That's where we downloaded from. You could either clone the repository if you're already using GitHub, that's what I did, or you could just download the zip file. And then just open it, copy the one folder inside there. You can put it wherever you want. For this test, I'm just gonna stick it to the root of C. So we have it here, and we go into that folder, and here is everything that's included in the P2PP script. But in addition to, like, P2PP is written in Python, so you need Python installed. They say that it can run with 2.7 or 3.7. I'm using 2.7 for everything right now, so I just stuck with that, and that's what I'm gonna do, because if you use 2.7 and install it at the default location, you don't need to do any changes to P2PP. If you use another version installed in a non-default location, then you need to go into this batch file and just update the path to the Python interpreter in there. That's just, they have a link here on the P2PP page to the Python download page. So if you want to go for 2.7, you can go here, install if you have Windows, like a 64-bit Windows, you go for the 64-bit version. If not, you go for the 32-bit version. I have 64-bit, so I will pick this one, download it, and then just run the installer. I already have this installed, so it asks me if I want to repair or remove. But this is like a standard Windows installer, so you just choose the default option for everything. If you leave the install location at its default location, it will create a folder on the root of the C drive called Python 2.7. And it will put installation there. If you just leave that at default, everything will work out of the box. If you choose another location, you will have to go in and modify that batch file. So let's go take a look at that. So here, this is a batch file that is used to launch P2PP. So let's edit that. And what? it's gonna protect me from changing that patch file. And it says don't run. I did choose edit, didn't I? Edit. Don't run. More info. I wonder if it will try to run it if I click this, or if it actually edits it. Let's try. And it edits it. Awesome Windows. And then it put everything on one line. What the? Okay, so this doesn't work. Let's can I do edit with Notepad++? Yeah, there you go. So you see here the path to the Python interpreter is hard-coded. So if you change the location, or if you install a different version, you need to update this to point to your installation of python.exe. That's all you need to change. But if you install it, like if you install 2.7 at the default location, you can just leave it as is. So then we go back to the web browser, we back out of the Python installation, and we go to this page. You have now installed all the software you need, so let's proceed to setting it up inside. Yeah, of course you need to have PrusaSlicer or Sleeker installed. That's another prerequisite that I'm not going to show here, but that's of course required. Now that we have everything installed that we need, we can configure PrusaSlicer 2 to invoke P2PP and configure P2PP to do what we want. So the first thing we need to do is to set up a new printer profile. So we go here. I will assume that you already have this slicer configured for your printer so that it works in single color mode. If you need help with that, you could tell me in the comments and I'll see what I can find. If I can find some tutorial that I can link to, or maybe I'll make some instructions for that too. But for now, I'm going to assume that you have everything set up so that it works with your printer in single color mode. And for this tutorial, I'm just going to base it off the original Prusa i3 MK3S, which is one of the standard printers that comes with PrusaSlicer. But you will start with whatever printer you have set up already for single color printing. So then the first thing you do is to increase the number of extruders. Palettte support 4 materials, so we're gonna stick 4 in there. And then we're gonna enable single extruder multi-material. We apparently are not. Okay, I had to tab out of that before I could get any further. I enable this. And then I go disable variable layer height, because that's gonna mess up the purging. Like it will have issues synchronizing the purge tower if you leave this on. So I'm gonna turn it off. Then I will go to the single extruder multi-material setup, and here this is for the MMU2 multicolor unit from Prusa, I guess. So, but when you're using it with the palette, you just set them all to 0, like that. Then we go, we're just gonna look through all the extruders. The first one probably have the settings you already used for your extruder. And so you need like the nozzle diameter and all the other standard settings, which is depending on your printer. So you need that set up correctly, and then you need to ensure that all the extruder have the same values for everything except for the color. You want each of them to have a different color so you can identify them when slicing. So we can just leave the first one at yellow, which appears to be the default. Then we go and change the other one to some contrasting colors. So that was blue, yellow, yeah, green, I guess is fine. And the last one, let's make it red, or that's red. Okay, so now they all have different colors. Then we can save the new profile. So we just click this floppy disk icon, then we append something identifying it as a P2PP version of the printer. I just gonna call it -P2PP. Okay, So now we have saved the new profile. See, now you have, yeah, this is my old profiles. Like this is my default, that's the profile I use for single color printing. I have a CR10S, but it's heavily modified with a direct drive extruder and due to 32-bit board. So there's so many changes from the original CR10S, so I called it CR10K. Maybe because of my name or because of Cavionic, you can choose. And then I have the same but with -P2PP for the multicolor profile. But now we made a new one, which is based on the Prusa MK3S, and we called it -P2PP. This is all we're going to do for print settings for now. We're going to go back later and actually configure P2PP, but let's first go and adjust the print settings. Then we go to print settings, and we're just going to base this off the 0.2mm quality MK3 profile. First thing we do is to go to multiple extruders, and then we want to enable wipe tower. That was already enabled for this settings, and we want prime all printing extruders to be off. So make sure this is on and this is off. Then we go to the output options, and here you can specify a post-processing script, and that in our case will be P2PP. So let's first find the folder where we installed it. So I'll go to C, and we installed it P2PP master. So let's just copy the path, stick that in there, and copy the name of the batch file. I guess I could have typed those like 5 letters, but I'm lazy, so let's copy it. So now PrusSlicer will first, when you export G-code, it will first, why can't I get rid of that window? It will first generate G-code like normal, and then it will run this batch file to post-process the G-code. And then to make it compatible with the naming scheme that Canvas and Chroma use, you can add .mcf there. So then the name will be based on your input files plus .mcf.gcode instead of just .gcode. And that should be it for the print setting. And now we have to configure P2PP. To do that, we go back to printer settings, we select custom G-code, and scroll to the end of the start G-code. Then I will go to the GitHub repository again, because here there is some documentation for how to configure it, and here is a sample configuration, so I'll just start by copying that. So copy back here, and then I'll just paste all this in like so. This is going to be included in the G-code exported from PrusaSlicer, but as you can see they all start with a semicolon, so the printer won't care their comments, but they are picked up by the P2PP script and used to configure it. So the first thing you have to do is to give it a printer profile ID. That is what the Palettte used to identify your printer. If it sees a new ID, it will tell you that this is the first time you have printing with this profile, and it will go through the initial calibration sequence. But if you pick an ID that you've already used from Canvas or Chroma, it will just use the old profile and no recalibration is needed. So to find that ID, you can take an mcf.gcode file that you have already generated with Chroma or Canvas. If you use Canvas and I've just always sent it directly to the hub, you need to download one of those files or extract it from your Canvas hub. You can download it from there. But you need mcf.gcode file to get the profile ID. If you haven't used any of those, I guess you will just have to set up either Canvas or Chroma and slice a file just to get this ID. I'm not sure if there is any data embedded in this, or if it is just a 64-bit random number, so you could just use a random number generator and make one yourself. But I would recommend at least doing the calibration and initial setup with Chroma or Canvas, and then just steal the ID from here. That's also what they recommend on the documentation for P2PP. So to find the ID, you look for the O22 command. You skip this D, that's not part of the ID. Then you select the rest here, copy that, back to PrusaSlicer, and you just replace this with the ID. Then you have the splice offset. This is the same as the change target, or what is it called? Let's go to Chroma and take a look at the printer profile here, so that you can relate the settings. If you used Chroma before, then this will be familiar to you. You can set up the purge length. You see I maxed this out now for some tests I did, and I've set the target position to 50%. I think that is like default 40%, and this is default 140 millimeter, I think. So the target position is basically telling it where on the purge block the actual transition is supposed to happen. Let's say you set it to 10%, then it will only print a little bit of the old color before it starts transitioning to the new one. That gives it a lot of filament to do the actual transition, so you will have a greater chance of having a clean transition at the end of the purge block, but it gives very little room at the beginning in case the printer had consumed a little bit more filament than estimated. Then you might actually start transitioning on the object before you go to the purge block. And the same if you put in a too high percentage there, it will wait too long before actually transitioning on the purge block, and you risk not being done purging before it's done transitioning. So then you will get bleeding of the old color into the new color. So I've set it, like I said, I think it's default 40, I set it to 50 here. But when we're setting up P2PP, I'm gonna use the default, I think 40%, and I'm gonna use a transition of 140 millimeter. So this is the settings we're gonna replicate in P2PP. So let's go back. First, the splice offset is telling P2PP how long into the purging that the actual splice is supposed to be put. So the default in Chroma was 40%. 40% of 140 millimeters is 56 millimeters. Let's put that in there. And then you have the minimum start splice, 100 millimeter. This is limitation of the Palettte. The first splice has to be at least 10 centimeters. Every other splice needs to be at least 8 centimeters or 80 millimeters. So you should just leave this as they were. Then you have the splice tune settings, like the splice profile, so material profile. These should also be familiar to you if you have used Chroma and if you have ever had to do some splice tuning. So let's again go back to Chroma and see how it is done there. And then we go profiles, material profiles, and then we can go edit the PLA profile. This is the settings for PLA to PLA. I'm just using the default 000. That works fine for me with the PLA. And here you can see PLA 000. So that is, you see here you have heat, compression, cooling, and that's the heat, compression, cooling in these three numbers there. But if you look at my PLA to PVA profile, so the default soluble, I use PVA for soluble. Here I had to tune it to make strong splices, and what I ended up with was 6 for heat, 4 for compression, and 5 for cooling. And I have it symmetric. I could probably tweak this better, but this works fine for me, so I have the same settings for both directions. So we need to replicate that here, and you can see it already have PVA to PLA, so we will just copy the numbers, which was 6, 4, 5. Let's double check that. 6, 4, 5. But it doesn't have a PLA to PVA. You need them both ways. So let's copy this line and just swap the two materials. So then we have a PVA to PLA and a PLA to PVA. So now it knows how to splice both ways. And then we go down to the linear ping. I recommend turning that on if you don't have this line in here. It will use exponential ping, which means that instead of having a fixed distance between each ping, it will have an exponentially increasing distance. Pings are used to inform the palette how far the printer have actually progressed, like how much filament it have actually used. And that is used to continuously recalibrate everything. So if the printer uses a little bit more, a little bit less than what the Palettte assumes, it will have a chance to correct itself. So that you keep the splice lengths correct all the time. If you don't use linear pings. The distance will increase further and further, and if you have a printer that has some variation in the amount of slippage you have in the extruder, for example, so the actual usage varies a little bit, you can get problems if distance between pings becomes too big. So I would recommend just keep it at linear ping. In addition to turning on and off linear ping, you can also set the linear ping length. So that wasn't part of that default settings I copied out of the documentation, but it is mentioned later down. So let's just stick that in there. Here you can set the number of millimeters between each ping. This example I just used 500, so 50 centimeters. You can play around with this to see how close you need them for it to stay in proper calibration. For my printer, having them very tight isn't causing any ill effect, but every time it pings, it has to flush the printer's pre-planning buffer, and that's a buffer it used to smooth out the time it takes to calculate stepper motor instructions from actual G-code instructions. So when it's told to go from A to B at a certain acceleration and stuff like that, there is a bit of processing going on, so it might not be able to do that quick enough to keep the stepper motors running smooth. So it have like one process calculating the high-level G-code and generating low-level instructions for the stepper motors, which is then put into a buffer and then executed by a low-level loop that will ensure that the motors are always running smooth. When you flush that buffer, you might get a small stall. So like suddenly the stepper motors don't know what to do and they stop for a little while and then they start going again. If you have a 32-bit, like I have this Duet to Ethernet, which has a 32-bit ARM processor, and the stalls I get is very, very minimal, if at all. So I don't have any ill effect from the pings. If you have an 8-bit controller, the situation might be different, because you might get much more severe stall when it has to flush that buffer. If that is the case, you might want to increase this number as much as possible without it affecting the calibration. So you need to find a sweet point there between it struggling to keep in calibration and on the other side having too many stalls during the print, which might affect your print quality. So, but 500, they recommend not going below 300, but there is actually a bug in P2PP right now. If you go below 350, you will get an error message, because they are checking that you are not trying to go below, according to the documentation, below 300, but there is a bug there. So if it's below 350, it will give you a warning, and it will actually then use 300 for anything of 350 or below. The actual length it will use is 300. So that's a bit messed up, but 500 should work fine. Then you have the extra end filament, which tells how much filament should be left when the print is done. Basically, the distance from your nozzle to the end of the filament. To calculate this, you take the distance between your nozzle and the Bowden tube, basically the length of your hot end, plus the length of the Bowden tube, plus the length of the extruder, plus a bit more so that you have something to grab onto to pull the piece out when the print is done. If you have a direct drive extruder, you just put in the length of the entire extruder hot end unit plus a little bit so you can grab onto it afterwards. This is to ensure that when the print is done, the palette will cut the filament, and it needs to cut it long enough that when the print is actually done, there is still some filament for the extruder to grab, and also a little bit sticking out of the extruder so that you can remove it after the print is done. So that's how you calculate this. And then the rest here is for side transitioning. So it basically, if you use side transition instead of purge block, it will just move the nozzle outside of the bed and dump the filament there, which is a really nice feature, but it requires you to set up some kind of wiping system so that it can clean the nozzle before it goes back to the print, and it requires that your printer can actually move the nozzle outside the bed. My printer can that, but I haven't made the system for wiping yet, so I haven't really played around with this. But you set positions and some other things, and then you can also run some custom G-code commands before and after the wipe, like for example if you want to move the head forward back a few times to wipe it properly, something like that. But this I have never played around with. I'll just leave it as default. So that's it for the start G-code. Well, most of the configuration is in there. Then you have to add one line after the code already in after layer change G-code, and here you put this line in, so semicolon layer, square bracket, layer underscore num, square bracket end. And that's it for configuring P2PP. Now let's configure the filament. there is a weird issue happening if you don't go in and change some setting on the filament. Like at the end of the print, it will go over the purge tower and dump a lot of filament there, independent of how tall the purge tower is. So if you have a model that has multiple materials at the bottom but not at the top, the head will actually be like it will stop producing the purge tower, but then it will go over the purge tower and dump filament there anyway at the end, like try to purge more. To avoid that, you can go in and select the filament you want to use. If you already have a custom filament profile, you could just go and modify that. Or if, let's say, you normally use the generic PLA profile, you can go in here and you can go to Advanced. Then you click Ramming Settings and close this. Then you set this to 0. Why can't I just type in here? Do I have to actually click down? Okay, so we put this to no ramming at all. Okay, then we save it as a copy. I just put custom in there. I don't want to overwrite my already existing custom, so let's just leave it at copy, PLA copy. And then maybe you want to use PVA for soluble supports, so let's do the same here and set it to 0. Okay, save this as a copy. Okay, so now we have 2 materials we can use with the ramming disabled. That's a thing for the MMU2, and it messes up for P2PP. Then we have to configure Purge Volumes. So then we go to the Platter tab and we click Purge Volumes, and then you get this dialog. Okay, it remembers the values I had from before. I think the defaults here are like 70, and so I want to show you why I put 168 instead of 70. And that's basically in Chroma. Let's go back to Chroma, I guess, and go back to the printing profile. And here you have this slider. So like I said earlier, I was going to base this off 140mm purge length and get that same amount of purging in P2PP. We need to do some calculations. So since here we have 140mm of filament in PrusSlicer, it is based on cubic millimeters of filament, and 1 millimeter of filament is approximately 2.4 cubic millimeters of filament. So to get from the 140 millimeter of filament length to the purge volume, we do 140 times 2.4. That equals 336 millimeters. But since this specifies like unload and load, how much it's gonna unload of the previous material and then load of the new material, we need to divide that 336 by 2 and put that number in this. So basically what we do is we take the old value of 140mm filament, multiply it by 2.4 to get the cubic millimeters, then we divide it by 2 and put each half into each of these. That turns out to be 168 cubic millimeters to get 140mm filament used in the purge. As you can see, you can have different values for the unload and load. So if you want to fine-tune this, you could, like if you're going from a weak color, maybe white, to a strong color, maybe some deep red, then maybe you want to make this asymmetric, so you get more purging when you go from, let's say, red to white than when you go from white to red. So you can make this asymmetric by taking the total amount you want to purge and divide it differently between the loading and unloading. But I've never messed with that. I just set it to the same value, so that I calculate how much I need in total, and then I divide it by 2 and put 1/2 in each. So this tells it how much to purge, basically how big the purge block will need to be. So then we should be good to go. Let's try to import a multicolor model and see how this all works. Here is a 3-color penguin that I downloaded from Thingiverse. Let's drop that here. It asks if multiple objects were loaded for a multi-material printer. Instead of considering them as multiple objects, should I consider these files to represent a single object having multiple parts? Yes, that's exactly what I wanted to do. So we then, it's in the preview mode. So then we got this model. If I unselect it, you can see that it have multiple colors. this is the different models, and you can see they have been assigned the 3 first extruders. So we can go in and change it, like if we want it to be only 2 colors, we can do this. So now the body and the pupils and the eyes are all the same material. That's boring. Let's put it back to the first extruder. So now we have 3 different colors. And here you can see the purge block that it will generate to facilitate those color changes. You can move it around. In the settings, you can set the multicolor settings. You can change the width of it, and then it will just make it as long as it need be to fit the volume you're configured in here. So we'll just leave it there, and then we go slice. And now this is the final shape of the purge block. You can see if we drag down here, it starts with using all the 3 colors. So here it has the full size of the purge block. This isn't how the purge block will look when you're actually printing, because this isn't accounting for the first splice offset that we configured. So it will actually move these offsets. You see there is only a tiny bit of the first color before it switches to the next, so that this will actually be dragged over there, and the divisions will be a bit different. So this representation is not very accurate, but it shows you the size. And as it goes up, you see we're still using all 3 colors here, but now when you're getting past the legs, it is only using 2 colors. So now half the purge block is actually empty. It's just infill to keep building it, because it knows that it will need it later. But you can see the actual volume purged here is much smaller than the total volume of the purge block. So as we go up, it will keep just being 2 colors. Then for a little while we have only 1 color, and then we start getting 2 colors again. Still only half the block, and then here we are back to having all 3 colors, and you have some layers of solid purge block, and then we're back to using only 2. It was hard to see. Oh yeah, okay, so from here on to the top, we're only using 2 colors. Now it actually reduced the total size of the purge block until about this point there, and there it stops building the purge block because the rest is just a single color. And okay, yeah, here, let's see if we can visualize that better. You see, when we come to the top, it will do what I talked about earlier. It tries to extrude some filament in midair. By the way, the reason for that is that we have not switched to use the modified versions that we made. Why isn't my new... Didn't I save a copy of the PLA? That was odd. That was weird. Okay, let's go back to filament settings then quickly and clear the running settings. Okay, I wonder what happened there. But okay, let's save this copy. Go back here. I should now have... this time it works. Okay, whatever. Set all the extruder to this. Slice again. And voila, now that midair printing is no more. Awesome. So far so good. We've sliced it now. We've set up everything. So let's try to export. And you see it has now put the mcf.gcode instead of just gcode. The rest is based on the models. So let's just save this here. And whoops, not happy. Okay, short first splice. Remember we configured the minimum length of the first splice to be 100 millimeters. Short first splice smaller than 67. I guess this is what it probably meant to say, that it's smaller than 100 than it is actually 67 point blah blah. But whatever. We are smart and understand what it means. This model have a 2 short first splice. Let's just go back here. Yeah, so the first color basically is less than 100 millimeters, which makes sense. It's a tiny model. So one way to fix that, actually the only way I know, is we can go to print settings, skirt and brim, and we can either increase the loops or we can say the minimum filament extrusion length. And that is, if we hover over that, generate no less than the number of skirt loops required to consume the specified amount of filament on the bottom layer. For multi-extruder machines, this minimum applies to each extruder. I have not found a way to make it do it for only the first color, which is annoying, but at least it will fix our problem. If we put this to 100, we tell it to spend at least 100mm of each filament on the first layer, and that should fix this problem. So if we now try to slice it again, you see it will put a lot more skirt circumferences on it, and hopefully we will now have enough filament to get past 100mm. Try to export again, save, and yeah, now it was happy. We can go here, verify that it used the splice offset was 56mm like we configured, and here it dumps all the splice lengths and where it will put all the pinks. So nothing you normally care about in here, so you could just press space to get rid of it, and voila, now you can send that file to your canvas hub and print this model. But let's go through one more thing. So now we have spliced this multicolor model, but let's take a look at supports. If we go down here, you see that this model has some unprintable overhangs, so it actually needs supports. So let's first go and turn that on. Support material, generate supports, go back, slice it again, and now it should print properly, but of course you will have all the normal issues with supports, that they are a bit hard to remove and they will put marks on your model. So to avoid that, you can use soluble support. That is an awesome feature that I use a lot. That's basically my primary usage of the palette. I don't that often print to multiple colors, but I use PVA for soluble supports a lot. If you download random models that aren't maybe made for 3D printing, they often need a lot of supports, and that can totally ruin the print qualities. And if you're a designer and make your own objects, the design freedom that the soluble support gives is just awesome. You can make the models exactly the way you want it, rather than having to work around the limitation that MDF 3D printing gives. So overhangs isn't much of an issue anymore when you use soluble supports, other than of course the extra cost and time it adds to the printing, but the quality is very high when you use that. So let's try to convert from this normal PLA only support, or whatever material you're printing in, to a combination of the material you're actually making the model of and PVA for the soluble interface layer. I'm not going to print the whole support in PVA. PVA prints very poorly and it's very expensive. So if you try to print all the supports with PVA, at least in my experience, that would not be very easy, because the print would probably fail. And also you would waste a lot of PVA, which is several times more expensive than PLA. So a very good way to solve this is to print the supports in PLA all the way up almost to the model, and then just the last few layers is printed with the soluble support. So if you then just dissolve the interface layer, the PLA will just drop off. And I've used this even when the support like enclosed inside the model, so it can't really get out, as long as you have access to it, which you always will, because if it was completely enclosed you would just use normal infill. So then I've always been able to like stick a pointing plier or something in there, or a screwdriver, and just crush the PLA into small enough pieces that I can just get it out after dissolving the interface layer. So let's first start by selecting, like this model only used 3 colors, so we have one extruder free for the interface material. So let's then select PVA for that one. Then we go back to print settings, and we first we have to, this one I can select, okay. I think it will ask me when I choose the set distance. When you use soluble, if you use PLA or the same material for the supports as for the model, you normally want to put a small distance between the support and the model to make it easier to remove later. But when you're using soluble, you want it to be attached to the object. So you set that to 0. Then it will ask me for the wipe tower to work with soluble support. The support layers need to be synchronized with the object layers. So yes, I want to turn that on, and then it puts a check on this guy. Without that, this won't work. So, and then you have the number of interface layers. I find that 2 is not enough to make a smooth surface. So I use 4 or 5. Let's use 4 in this case. So other than that, you just do whatever adjustments you want here for how you want the supports to print, but the defaults are fine usually. Then you go to multiple extruders, and you see here you have a settings for support material and raft interface extruder. We set that to 4, which is the extruder that we had free and that we now will print PVA with. And the rest here should be fine. So let's go back to the preview and slice it and check out how this looks. So you see here now it have used random colors, whatever was in the extruder when it needed to print the support for the lower part. Then it switched to extruder 4, the red one, for the last few layers. And the same here to support the steep overhang that you have around the model. And the supports that started on the build plate is just PLA all the way down. For those that start on the model, it will also put the interface layer of soluble support on top of the model before it starts building the rest of the support. And then you of course have some vertical clearing that you can also configure so that there will never be any PLA to PLA contact here. So that makes it very easy to remove. So let's take a look at how this is built up. So you see it builds the PLA support, and then it starts covering that with soluble, and then it prints this overhang. Is now very well supported on top of the PVA until it connects with the rest of the model. And then as the overhangs is done printing, it will just stop the supports. And here the same for the beak. It just builds PLA up and then terminates it with PVA. And now this model will print perfectly. You just normally, even though it is water soluble, but the bonding between PVA and PLA is so much weaker than the PLA to PLA bonding. So I rarely stick them in water. I just peel them off. But if they're inside the cavity or something, you might need to actually stick it in water and dissolve it before, sometimes like crushing the rest of the support and picking it out of the model. PVA dissolves fairly slowly in water, so what I do if the model is small enough is to actually drop it in my ultrasonic cleaner. That makes it dissolve a lot faster. If it can't fit or you don't have an ultrasonic cleaner, I guess that's an option, then make sure to agitate it every now and then to reduce time it takes to dissolve. Otherwise it can take a very long time. But that's how soluble support works. Of course, that made the purge block quite a bit bigger because it now in some layers have 4 colors instead of just 3. But if we take a closer look at it, you will see that large parts of it will be hollow. Yeah, you see here we have everywhere where we have both the 3 original colors and the support interface, it will be solid. But then when we go down to here where we have only 2 colors and no support interface, then only a third of the block is actually used. The rest is just empty space. Then we come down here where we start having here we have like 2 colors per interface, so we have 3 transitions. Then it's mostly empty again, and then we come down here where we have also 3 colors plus the interface, so we get the solid block. So that's how you use P2PP. I actually switched to it at some point where I was printing some objects where the first layer filled almost the entire print bed on my CR10, so 30 by 30 centimeters, and I had soluble supports starting on the first layer. What happened then with Chroma was that since it only generated pings on the purge block, it printed so much PLA of the same color before it got to the first transition. So the printer was already enough out of sync that the first transition would fail. It would miss the purge block. And there was no way for me to make it work because the first layer is usually extruding a little bit less than the rest of the layers because the nozzle is squished toward the build plate. So it didn't spend enough PLA before it got to the transition. So when it was going to transition for the first time, it would just fill the whole transition block with PLA and then continue using PLA for the first interface layer. So then I tried P2PP, and since that one is generating pings independent of the transitions, it would have enough pings up towards the first transition that the actual transition was perfectly positioned and the print succeeded first try. So unless you run into problems with the pre-planning buffer or the motion planning buffer that I talked about earlier, there is no drawback with this way of doing the pings, and the benefits for me has been great. Also, I'm using an external buffer on my Palettte to be able to print at higher speeds than normal. You might have seen that in some of my other videos. And that has two side effects, one good and one bad. The bad is that it adds a bit of inaccuracy because the filament going through the buffer, it sometimes isn't always following the same path. So the amount of filament inside the buffer will have slight variations, which adds to the inaccuracies in calibration. So I need a little bit more purging because of that. In addition, the point of the buffer is to be able to print at higher speeds, and when I print at more extreme speeds, like past 200 millimeters per second, the variation in extrusion from the printer itself gets much bigger because the variation in back pressure from the nozzle is humongous when you're printing at those speeds, because when it is actually doing 200 millimeters per second, it is like flooding plastic through the nozzle and have huge back pressure. And then you get into a corner and it has to slow down and the back pressure drops to almost zero, and then it speeds up again and you get a huge back pressure. So you have much more variation in extrusion, and thus you need much more feedback to the Palettte to allow it to keep track of what the printer is actually doing. And in my experience, the way P2PP handle pings, it makes it much more able to react to changes in the printer. And with a bit bigger purge block than you would get away with printing at lower speed without the buffer, it is always able to perform the transitions properly without any bleeding. And of course, since my primary usage is for soluble support, it's super important that it is not bleeding, because it's not causing a visual artifact. It actually totally ruins the model, because you get soluble support into maybe a structural part of the object and it will just fall apart afterwards. But that's it for the P2PP and PrusaSlicer. I can highly recommend it. I'm very happy with it, and I want to say thanks a lot to the developers of it. Go say thanks to them as well. And that's it for now. See you later. If you liked this video, please click the thumbs up. If you didn't like it, then click the thumbs down and tell me in the comment why you didn't like it, so maybe I can fix it next video. Bye bye.